There are always new people coming online, and this is a sort of patch video for them mostly, although I think it sounds quite interesting at the end. So what we're going to do today is do a very simple patch using the sequencer. So first of all, let's just set up the environment. So we have the sequencer. So we're going to take the control voltage out, and I'm going to put that into the input of the attenuverter. We take the output of the attenuverter up into the multiple. I'm going to take multiples to the pitch ins on the oscillators. So what this does basically, it now means that this is basically wired in parallel with the existing pre-connected inputs for the oscillator frequency. Now because we are adding potentially a little bit of with the attenuverter, we can get different sounds. So let's go back again up to here, sorry. So control voltages. The control voltage that the keyboard is generating is available on this output, but it's also sent to both these oscillators. These inputs are then also added to that control voltage, plus any voltages coming from the modulation section. These inputs are 1 volt per octave, which basically means that if you add another voltage of say 1 volt, then the oscillator will sound 1 octave higher. If it's a half a volt, it'll sound half an octave higher, etc. A 1/12 of a volt, it'll sound 1 semitone higher. Subtract a 1/12 of a volt, it'll sound a semitone lower. Subtract a whole volt, I put a volt of -1 in, which will get added to the existing, it'll be an octave lower. So these inputs are added to the existing control voltage. Using the attenuverter, which can do basically up to +1 or -1, we can take the control voltage and convert it basically make it a negative value, such that it matches these outputs and match the hardwired value exactly oppositely. So what happens is that now the oscillator, when it adds those two signals together, doesn't see a difference as it changes. So now both oscillators are completely in drone mode. Constant frequency, sorry. Now we can go from that, we can go back to roughly where 0 is. And so basically we're not adding any extra voltage. And we can also add a lot, double it up. So we're now basically going up a whole note every semitone. So for the rest of this patch, I have no resonance, I have some envelope amount, I have the filter cut off fairly low down, a long release. This is going to be used later. So this just happens the way that my oscillators are tuned. The fine tuning here adds yet another voltage into this oscillator's input, control voltage input. And I have a little bit of springline reverb. Okay, so let's get back to the sequencer. So we're going to put the sequencer into record mode, and we're going to play a note, and we're going to add 3 rests, play another note, 3 rests, another note, 3 rest, another note, 3 rests, another note, 3 rests, another note, 3 rests as an example. So any pattern you want to put in there, it's up to you, but we're not going to play in the pattern, we're going to use the random sequencer. So we're going to, let's see what we got. So the drum machine started as soon as I hit the play button, and that's going to give us like a reference 4 beats. So we're now going to switch it into random sequence. So the drum machine is being driven through the MIDI interface, MIDI out. So the last piece of patching I'm going to do is I'm going to take the gate out on the sequencer to the sync input on the LFO. On the modulation, I have a reasonable amount of cutoff modulation, and I have the ramp down waveform. So when I increase the modulation depth, we have the LFO using the cutoff to provide a interesting echo style effect, even though it's only purely done by the LFO and the filter cutoff. So we're not limited, obviously, to sort of fairly random numbers, random notes. We can try recording other sequences. We can do a simple pentatonic. We also need the spaces to give us the bits in between. Random mode. So a simple patch which you can have a lot of fun with. Shades of Subotnik.